This is rope. This is rope. And this is rope. They all look similar, but looks can be deceiving. Selecting the right rope for the job is essential to a safe lifting environment. But in order to do that, you need to know the difference between the types of rope and when to use which. It's Nate again with GME Supply, and welcome to Ropes 101. In this video, we're going to go over which rope is right for what jobs and why. There are three main types of rope that you will need in typical industrial and at-height applications. Those three rope types are 3-strand, kernmantle, and double braid. The main difference between these ropes are what's below the sheath, which is why they don't typically look all that different to the untrained eye. Let's start with the oldest, the 3-strand rope. This is the granddaddy of rope. In fact, earliest evidence of the use of 3-strand rope was in the building of the pyramids of Giza. 3-strand ropes are made of 3 strands. Each strand is made up of very small fibers of yarn twisted evenly and pulled tight. These strands are then held together at fixed point and twisted together once more until the entire length is uniform. 3-strand ropes tend to have a lower minimum breaking strength or MBS than double braid or kernmantle. Due to their construction, 3-strand ropes have a tendency to rotate under load and provide less abrasion resistance. Because of this, 3-strand is a poor load line, but is commonly used as a lifeline due to compliance with OSHA and compatibility with a 5/8 rope grab. Now, on to kernmantle rope. Kernmantle rope is made up of loosely twisted parallel fibers called the kern, surrounded by a tightly braided sheath called the mantle, hence the name kernmantle. The core fibers provide about 70% of the rope's strength and help to keep the rope firm yet flexible, while the sheath or mantle's tight braiding gives kernmantle rope a significantly higher abrasion resistance than 3-strand or double braid. Not all kernmantle ropes are the same. Kernmantle ropes are further divided into two distinct types: dynamic and static. Dynamic is the most popular because its high shock absorption capabilities make it ideal for recreational climbing. Static kernmantle has very low stretch and works well for industrial applications because it remains round through descent devices and allows minimal twist on the rope. Static kernmantle's ropes properties make them ideal for use as a lifeline or descent line. Both static and dynamic kernmantle ropes have a textured sheath to protect the core from dirt or particles. The sheath also helps generate some grab and friction for rappelling or lowering operations. Finally, let's talk about double braid rope. Double braid rope is a braided core surrounded by a braided sheath. The inner and outer cores are generally designed to share the load equally with very little elongation. It remains round under tension, imparts no rotational force when loaded, and has a soft hand, which makes it ideal for use as a load rope. One major advantage of double braid rope is that it can be made up of 2 different fibers to create a rope that merges characteristics of different materials. Now that we've covered the basics of each type of rope, let's go over some of the best practices that you should have regardless of what type of rope is right for your job. One common misconception is that the thicker the rope, the safer it is. In reality, your rigging is only as strong as your weakest component, so if you have a 1,000-pound capstan hoist, most 1/2-inch double braid rope has a high enough MBS to handle the maximum load for your hoist, even when incorporating the safety factor and any loss of strength due to knots, termination plates, or sewn eyes. Another factor to consider is the sheave diameter of the blocks you are using. Many options can handle 1/2-inch synthetic rope, but few exist that are strong enough to justify the use of 5/8-inch rope. Always keep in mind what knots you're using and how they affect the strength of your rope. Knots can seriously decrease the overall strength of rope, not just while tied, but also after it is removed due to crimping and twisting that is often irreversible. Knots can decrease rope strength by up to 50%, which could be catastrophic in a life safety or overhead lifting and rigging situation. So it is vital to not only know how to tie different knots, but what the purpose of each and when to use them are. If you need some help, check out our playlist on how to tie the most common knots for the at-height industry right here. A common reason knots are tied in rope is to create an attachment point to secure a rope to a structure or object. Instead of using a knot that could impact the rope's MBS, consider using a termination plate. Termination plates are a piece of machined metal that have multiple holes to weave rope through. The main hole at the end of the plate is your attachment point. If you aren't comfortable with rigging a termination plate, most at-height rope can be bought with either factory sewn or spliced eyes or specific connectors at the end of the rope. Those termination options allow you to avoid needing to use a knot that could impact your rope strength and cause an unsafe situation on one of your job sites. So, the next time you think about rope, remember that selecting the right rope for the job is essential to a safe lifting environment. Hopefully, you learned a little more about the types of rope used in industrial applications. If you still have questions, give your gear experts a call at 800-940-6762 or chat with us at gmesupply.com. If you enjoyed this video and want to learn about the newest gear, safety tips, and quick refreshers on safety, be sure to subscribe, ring the bell for notifications, and check us out on social media at GME Supply. Thanks for watching, and we'll see you in the next video.